Today I'll talk about pressure and pressure measurement summary. Now first I talk about what is the pressure definition. Definition of pressure at a point is like that: the inward force applied perpendicular to the surface of an object per unit area at a specific point. So formula for pressure: P is equal to F by A. What is P? P is pressure, F is force applied, A is area over which the force is applied. Remember some key points. Pressure is a scalar quantity. SI unit of the pressure is the Pascal. Pressure acts perpendicular to the surface. Smaller area means higher pressure for the same force. Now here I am talking about units of pressure and conversion relations. Units of pressure: MK system, Pascal or Newton per square meter; CGS system, Bay or Dyne per square centimeter; FPS system, pound force per square inch; and SI system, Pascal. SI and MK system units are nearly same. Conversion relation: MKS to CGS, 1 Pascal is equal to 10 BA or 1 Pascal is equal to 10 Dyne per centimeter square. MKS to FPS, 1 Pascal is equal to 0.00145 psi. So I have given here that CGS to MKS, CGS to FPS, CGS to SI. So an FPS to SI, SI to MKS, SI to CGS, and SI to FPS. You can go through it and you will easily get it. Next is Pascal law and pressure variation in a fluid at a rest. Pascal's law states that a change in pressure applied to an enclosed fluid is transmitted undiminished to all portion of the fluid and to the walls of its container. Pressure is transmitted equally in all directions throughout the fluid. Now pressure variation in a fluid at rest. Hydrostatic pressure: the pressure exerted by a fluid at rest due to the force of gravity. Formula is P is equal to rho gh, where P is pressure, rho is density of the fluid, g is acceleration due to gravity, h is height of the fluid column. Pressure at a point in fluid is the same in all directions. Pressure increases with the depth in a liquid. Now column height and atmospheric pressure. So now here is some concept. Column height is associated with the atmospheric pressure when a column is filled with a liquid. Different fluids have different column height for same atmospheric pressure, like water. Column height: for water, the column height for 1 atm pressure is approximately 10.33 meter. So we can easily prove that. So we know P is equal to rho gh, so h will be P by rho g. Similarly, if I take mercury in the column, so what will be the mercury height? For mercury, the column height for 1 atm pressure is approximately 760 centimeter, and we can easily prove that. So here hg is equal to P by rho hg. Now I am going to prove that. Now here H water is equal to P by rho water into G. So P is 101.325 Pascal. Now we are here that rho of water is 1000 kg per meter cube, G is 9.8 meter per second square. From here that height of the water is 10.33 meter. Similarly, height of Hg, so here P is 101.325, same pressure, and density of the Hg is 13,600 kg per meter cube, and G is 9.8 meter per second square. So it is approximately 760 centimeter. Now pressure calculation for fluid columns. So now if if same height but different density is there, so what will be the pressure? So we know the pressure formula: P is equal to rho gh. P is pressure, rho is density of the fluid, g is acceleration due to gravity, h is height of the fluid column. Now here if we take the water and if height is 0.3 meter, so from the relation P is equal to rho gh, so we can easily calculate what will be the pressure at the bottom of the water. That height is 0.3 meter, so that will be 2940. If we take oil and it is filled 3 meter, so bottom of that column, what will be the pressure? So that will be 2352 Pascal. For mercury, that will be 39936 Pascal. So simply we just use H is equal to rho gh. From that we can easily calculate. Now here absolute pressure, gauge pressure and vacuum pressure. So absolute pressure, what is that? PAVS. The total pressure exerted by a fluid including atmospheric pressure. So that is called absolute pressure. So formula is P absolute is nothing but P atmospheric pressure plus P gauge pressure. Example, if atmospheric pressure is 101.3 kilopascal and gauge pressure is 20 kilopascal, so absolute pressure is PAVS is equal to 101.3 plus 20, so 121.3 kilopascal. Gauge pressure, the pressure measured relative to the atmospheric pressure, means above atmospheric pressure is actually gauge pressure. The formula is here P gauge is equal to P absolute minus P ATM. Example, if absolute pressure is 150 kilopascal and atmospheric pressure is 101.3 kilopascal, so gauge pressure or gauge pressure is P gauge 150 minus 101.3, that is 48.7 kilopascal. Now vacuum pressure is less than atmospheric pressure. The pressure less than atmospheric pressure. Formula is P vacuum is P ATM minus P absolute. For example, if atmospheric pressure is 101.3 kilopascal and absolute pressure is 80 kilopascal, so vacuum pressure is P vacuum 101.3 minus 80, so 20.3 kilopascal, that is vacuum pressure. Now here one example is given. So parameters are given. Density of liquid is given 1.53 into the power 3 kg per meter cube. Atmospheric pressure is given P ATM 750 mm Hg. Specific gravity of mercury is given, so that is 13.6. Density of water is given 1000 kg per meter cube. Depth below the free surface, that is 3 meter. Now here we have to calculate absolute pressure. So P absolute we know P ATM plus rho gh for the liquid. P absolute water is P ATM plus rho water g into h. P gauge pressure P rho gh. P vacuum P ATM minus PAVS. Now here that PAVS for the liquid, so PAVS, so atmospheric pressure into that density, then G and into height, so that is 75187 Pascal. PAVS water for water referent, so that will be atmospheric pressure plus that 1000 kg per meter cube the density, so that then absolute pressure will be 78150. P gauge pressure for liquid, so that will be just minus atmospheric pressure from that absolute pressure, so that will be 45162 kilopascal. P vacuum for the liquid, so that will be P vacuum atmospheric pressure minus 750 plus 75187, so that is minus 75187 Pascal. Now pressure measurement device. So one pressure measurement device is piezometer. So piezometer is nothing but a vertical tube is connected to the pipeline. So we can, and that liquid will come to that small tube and it will rise. Due to the rise of liquid, we can easily calculate what will be the pressure. So pressure is again rho gh. Now one separate video is already there, so please you can go through it and you will get different type of pressure measurement device. So here pressure measurement by Utube manometer. So one end you can see that is closed and other ends is connected to the gas pipeline. So now here this gas density is H rho g, and A and B here reference line X and X dash. From here we can easily calculate what will be the PG. PG is nothing but HM, that is the mercury level height, into rho m of mercury into G if gas density is negligible. Okay, so this means how this pressure is calculated. So I have already made one video, so please go through it. So if it is open to the atmosphere again, so if it is a liquid, now that is gas, and if a liquid, so if liquid is there, then we can't neglect the density of the liquid. So PL will be HM rho mg minus HL rho L into G. And then manometer, okay, so again that is open to atmosphere pressure, open to atmosphere, so that is one end. So that we can easily calculate. So PG minus PATM is equal to HM into rho m into G. Here one limb is open to atmosphere, so here we can easily get what will be the that PG minus at P atm is equal to hm rho m into G. Now if it is in liquid, so then it will be PL minus P atm is equal to hm rho m in G minus HL rho L into G. Now if any fluid is there, so then that will be P atm minus PF is equal to hm rho mg plus HF rho F into G. Then if that water, suppose the liquid is flowing through a pipe, now if we want to measure the pressure, so we can connect the Utube manometer. So for that, so if we want to calculate what will be the pressure difference, P1 minus P2, that will be hm into rho m minus rho F into G. Now vertical single column manometer, so if you want to calculate pressure PA, so that is P2 G into H2 minus P1 G into H1. So separate video is already there, so please go through it. And single column manometer, so if it is a inclined manometer, so that is PA is equal to rho 2 G L sin theta minus rho 1 G H1. So H2 is equal to nothing but L sin theta. Now here differential manometer, so if that two pipes are difference level, from here we can easily calculate the pressure difference. So PA minus PB is equal to rho 2 GY plus GH rho 3 minus rho 1 minus rho 1 G into X. If two pipe at same level, so PA minus PB, that is equal to GX rho 2 minus rho 1 plus GH rho 3 minus rho 1. Now if it is a inverted differential manometer, so PA minus PB is equal to GX rho 3 minus rho 2 plus GH rho 1 minus rho 2. That's it for the summary of pressure and pressure measurement device.